So today we are going to discuss about the concept called as the routing in a computer network, right? So what is the routing first? So routing is nothing but it is a component which is going to have in a network layer. So mainly if we take a TCP/IP, so if we take a TCP/IP, TCP/IP will be having a 5 layers. Okay, the first layer is nothing but it is a physical layer. The second layer is the data link layer. Third layer is the network layer. The fourth layer is the transport layer. The fifth layer is application layer. So if we take a TCP/IP, so these are the 5 layers we are going to have. So the router it comes in the network layer. So what is the job of a network layer? We take a network layer. The main job of a network layer is going to assign a destination address to the packets. So the packets what it is going to have is from the data link layer, output is going to have is a packet. So to this packet, the network layer is going to assign a destination address. So destination address is the packet to where it should reach. So mainly it is going to assign destination address. Destination address is the packet to which it should reach. The packet where it should reach. So this is the one service of the network layer. So the next important service of a network layer is the routing. So this is the first one. Second one is the routing. So routing is here in network layer before transmitting or sending a packet to destination, it is going to find the shortest path. Okay. So routing is the one which is going to find the shortest path to the destination. The job of a router is to find the shortest path to the destination. The destination is where the packet should initially reach. Source is the where from which the packet is going to start, and destination is where it is going to reach. The starting and reaching is called as the source and the destination. So the routing mainly is going to specify which is the shortest path to reach the destination. So how many hop it is going to travel to reach the destination. So what is the hop? The hop is nothing but it is the next neighbor node. The hop is neighbor node. The neighbor node to reach a destination. So normally what happens if we take a network is going to have a many nodes or many computers or many devices. So when any source device sends a packet, the packet will not reach directly to the destination. In turn, what happens? It is going to travel to the intermediate devices or intermediate node. Okay, so that intermediate node or intermediate device is called as the hop. So the router, what it is going to do, it is going to specify the shortest path for the packet to reach the destination. Next, it is going to find the hop. The next hop is nothing but neighbor node. So from the source, which is the neighbor node. So which is going to, how it is going to find a neighbor node? So routing, how it is going to find the next hop? The router mainly is going to find the next hop by calculating the cost. Okay, so by calculating the cost, it is going to calculate the next hop. So which is going to have a least cost from this source to the next neighbor, that is going to be calculated as the next hop. That address is going to be noted. So the packet from this source, first it is going to go to that particular neighbor node. From there it is going to travel to the other node. So likewise, until it reaches the destination, the packet is going to travel from the one node to the other node, or one device to the other device to reach the destination. So that particular concept of traveling through the shortest path is specified by this router. So network layer, if you take mainly the network layer, it's going to perform the two main operations, or two main applications, or two main services. So one is that it is going to assign a destination address. That is the physical to logical address, so where the packet should reach. So next it is going to mainly specify the router. So router is that where the packet should reach and what is the shortest path to reach the particular packet to the destination. That is specified by the particular routing of routers. Okay. So now to find the shortest path in a network, mainly we are going to have two main algorithms. So one is the distance vector routing algorithm. So one is the distance vector for routing algorithm. So this is one algorithm which is able to find the shortest path, which is destination. This is the first algorithm. Second one is the register shortest path algorithm. Which is the shortest path algorithm. So this is the two main algorithms used to find the shortest path. Okay. So by using these two algorithms, this is the basic algorithm. So now you will see you might have n number of algorithms in a model. So whereas before in starting, people used only these two particular algorithms. It is the base algorithm for finding the shortest path in destination through the router. Okay. The first we are going to see about the distance vector routing algorithm. So the other name of a distance vector routing is the Bellman-Ford algorithm. So what is the Bellman-Ford algorithm? So Bellman-Ford algorithm is nothing but first what it is going to convert a network into a group or tree-like structure called as a graph. So in Bellman-Ford algorithm, the network is going to be converted into the tree-like structure. The converted into tree-like structure called as a graph. The tree-like structure called as a graph. Okay. So what do you mean by graph? The graph is something which is going to have a nodes and an edges. The graph is mainly what are these going to have? It's going to have a nodes and it's going to have a edges. Okay. So it's going to have a cost at the end of each edges. It's going to have a cost to each and every edges. Okay. So then what is going to do? The main element for algorithm is going to use the router. So what is the job of the router? I said. So the main job of the router is going to specify the shortest path to reach the destination. So how it is going to find is that the main is going to calculate the what is the next hop, what is the destination, and what is the cost. Okay. So all these details is going to be noted in a table that is called as the routing table. So you are going to use a table called as the routing table. So what is the job of this routing table? So mainly the job of the routing table is going to keep track the what are the nodes the packet is going to receive to reach the destination. Okay, that is the table it is going to have. So mainly what it is going to have? So it is going to have the next hop. So what is the next hop the packet is going to go? Which node it is going to go? That is the next hop. And what is the cost? What is the cost to go from the next node, from source to the particular next node? Finally, you are going to have a destination. So these are the details the routing table is going to have. In a router, you are going to have a routing table. The routing table is going to monitor all the activities of the packet from starting to end. Starting to end means from which source the packet is going to generate and which destination the packet is going to reach. So starting from end, the routing table is going to keep track all these things. So with the help of a routing table only, at the end of this thing, with the help of routing table, you are going to find the shortest path to reach the destination. Okay. So these are the main information the particular routing table is going to have. So once in every 15 seconds, the routing table is going to get updated. So once in every 15 seconds, routing table gets updated. So once in every 15 seconds, the routing table will be getting updated. Okay, why it is updated? We want to calculate the next hop address, the next node address, the packet address, where it is. Okay, so that is the main thing why we are going to update or why we are going to refresh the particular routing table. This is the main thing we are going to have in a Bellman-Ford algorithm. So now we are going to explain this particular algorithm with the help of an example problem. So for example, consider this. For example, consider this particular network. So network what is the network is nothing but a Bellman algorithm. It is going to be converted into a tree-like structure called as a graph. So it is going to have a graph. Graph is going to have a nodes and then edges. For example, if we take this network, so this is the example network where this network is going to have a node. So here if you take in this particular diagram, so what are the nodes you have? The A, B, C, D, E, F and G are the nodes. So you are going to have 7 nodes. What are the edges we have? So these are the edges. Okay. So cost is not specified, means you are going to take the cost as 1. Okay, so in any network, in any graph, for the particular node, the cost is not specified. Defaultly, we are going to take the cost as 1. So if the cost is specified, we are going to take the cost for solving the particular problem, right? So now we are going to see how we are going to find the shortest path to this particular network by using the Bellman-Ford algorithm. So this is the first shortest path algorithm used in a router, used by router to find the shortest path to the destination. First thing, we are going to see this particular, we are going to take this graph. So initially what we are going to do, we are going to see what are the distance from each and every node. Okay. So we are going to calculate the distance from each node. Okay. So what are the nodes we are going to have? Let's going to take it. A, B, C, D, E, F and then G. So next what are we going to do? So we are going to take the address. Okay, that is the next hop from the each and every. The next hop from the each and every node. Okay, so from A to A, from A to B. So from B to A to C, A to D, so A to E, then A to F. Okay, finally A to the G. Okay, so you are going to take the each and every node. So this is the first initial routing table you are going to calculate. So you are going to first fill it. So here, not to fill this one by using this network graph, we are going to fill the first table. So what is the distance we are going to calculate? From A to A, you do not have any distance, so you are going to put it as a 0. So next what we are going to have A to B. So we are going to see whether the path is available from A to B. So if we take from this diagram, you have a path available from A to B. So the cost is nothing but 1. So I said that default in the network, if it does not have any cost, you are going to make it as a 1. So here from A to B, you don't have cost, so you are going to make it as a 1. Okay. So from A to C, have any direct path? So no, you don't have any direct path from A to C. So you are going to put the infinity. The starting you are going to put the infinity. So why? Because you are not going to have direct path from A to C. Because from the A you are going to have a path from A to B, A to E and A to F. So other things don't have a path. So direct path which you don't have for that particular node, next hop you are going to put the infinity. Likewise, from A to D, if we take, we don't have a direct path, so you are going to put the infinity. So from A to E, you have a path. Okay, so from A to E, you have a direct path, so you are going to put the 1. So then, A to F, you have a direct path, so you are going to put the 1. So A to G, you don't have a direct path, so you are going to put the infinity. So likewise, you are going to put each and every node. Next comes for B. So for B, what are the nodes you have? So the next stop, if you take, you are going to B to A and B to C. Okay, so from B to A you are going to have 1 and B to C you are going to have a 1. So for other things you don't have a direct path from the B. Next stop, so you are going to put here infinity. You are going to put the infinity. So likewise C. So for C, what are the next nodes you have? C to B and C D. So from C, B and D you are going to have a path. So normally from B to B you don't have a path, you are going to put 0. Likewise, here infinity, C to C you don't have 0. So infinity, infinity, infinity. So likewise again D. So for D, if we take, you are going to have a next hop C and G. So from D, C and G are going to put a 1, and D to D is going to have a 0, the others are going to have a infinity. So likewise E. So if we take E, so what are the next term you are going to have E? For E you are going to have A. So for E you are going to have A. So next term we don't have a direct path. So you are going to put the infinity E to E 0. So next you are going to put the infinity. So likewise F. For F if you take what are the diagonals you have? Next term what are the things you have? From F to A, F to G. So F to A you are going to have 1, and then F to G you are going to have 1. And F to F you are going to have a 0, so others you are going to put the infinity. Are you able to follow? So likewise final one G. For the G, what are the next term we have? You can go from F, you can go to G. So F and G. So F and G 1. So G and G will be 0. So G and G will be 0 and F and D. D will be 1. So others is going to be a infinity. Okay? So that is the first table you are going to mark for each and every node. You are going to take each and every node and you are going to specify the next hop. So initially if you take the next hop, it will be only from the direct node. Okay? So this is the initial one. But we are going to calculate what are the other paths available to reach the nodes. Okay. So for example, if we take A, for example, I should reach D. So what is the path available? So normally what is the path available D? From A to B, B to C, C to D. So what is the cost? From A to B it is 1, B to C it is 2, C to D 1. So 1 plus 1 plus 1, 3. So this is the initial table we are going to have. So now what I am going to do, from this initial table we are going to find what are the other paths available to reach the from A to C, what is all path available? From A to D, what is all path available? From A to E, what is all path available? That we are going to fill in. So here, mainly the infinity, you have the infinity values, right? So that infinity value, we are going to fill with the other available routes. Okay? So, okay. So start from first one. So A. So A to A don't have value, so you are going to put 0. So A to B directly have one value, you are going to put 1. So come to A to C. From A to C, you don't have direct path. Clear? So you are going to have a next hop. So how many hops is going to travel? So from A to B1, B to C1. So totally how much? To reach from A to C, it is going to take a cost of 2. So you are going to put it 2. Same like that from A to D. So from A to D. So what is the path available? A to D, A to B, B to C, C to D. So how much value? What is the cost? From A to B it is 1, B to C it is 1, 1 plus 1, 2. So C to D is 1, 2 plus 1, 3. So here you are going to have a value as 3. Okay, same like that. From A to G. So A to G, what is the path available? How many paths are available? So 2 paths available for A to G. So what is the path available? So to reach from A to G, you are going to have the A to B, B to C, C to D, D to G. This is one path. Next, another path is the A to F is one path and F to G is one path. So now calculate the cost. So here if you take here 1, 1 and 1. So 1 plus 1, 2, 2 plus 1, 2 plus 1, 3, 3 plus 1, 4. So if you take this path, the reach here A to G, the cost is going to be 4. So if you going to take this path, the A to F, F to G, cost is going to be 1, 1. The total cost is 2. So here what you are going to do, you are going to take a minimum cost. This is a very important point. Okay, so if you take from A to G, you are going to have 2 routes. So one route is A to B, B to C, C to D, D to G. That is what we have written here. So A to B, B to C, C to D, D to G. So here one rule each one. So you are going to have totally 4. Cost is 4. So another path what you are going to have A to F, F to G. So this second path available. So what is the cost? A to F, F to G. A to F it is 1, F to G is 1. The total cost is 2. So from here we are going to calculate the least one. The least cost is 2. So to reach from A to G, the least cost is something like that 2. So you are going to put that 2 here. So this is for the one node A. So same like that we are calculating for the next node. Okay, A to D. So So A to B to D. So B you have. So D. So what are the paths available? So only one path available. B to C, C to D. So what is the cost? B to C is 1, C to D is 1. So 1 plus 1 total you are going to have it as 2. So this is the thing what we are writing, it is the final table, right? Same like that. B to E. So B to E. So B to E, what are the paths available? Yes. So here if you take, you are going to have only one path. So B to A, A to E. So B to A is 1, A to E is 1. So 1 plus 1, 2. So you are going to have a 2. So likewise, B to F. So B to F, how many paths are going to have available? So B to C, C to D, D to G, G to F. So what are the paths available for B to F? So B to F path available is, so B to C, C to D, D to G, G to F. This is one path. The other path available from this one B to F is what is the path? So B to A. So A to F, F to G. So what is the cost? For the first one, cost is 1, 1, 1, 1. So 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. For next path is 1, 1, 1. So total it is 3. So in this two paths available for A to reach F, you are going to take a least one is the 3. So you are going to put here 3. The same method for a B to G. So B to G. So get carrying B to G. So same like that. B to C, C to D, D to G. So 1 plus 1, 2, 2 plus 1, 3. 3 roots. Take 1, 2, 3. Then what is the other path available? B to G. B to A to F, F to G. So 1, 2, 3. So 3, 3 is common. So we are going to put it as a. Okay. Same like that we are going to put. So C to A. So C to A will take 1, 2. So you are going to have a 2. Okay. So then C to E. From C to E. C, D, G, F, A, E. Another path is C to B. 1, 1, 2, 3. Okay. So you are going to have a 3. So likewise, they are going to fill for the every other tables what you are going to have in this routing value. So the value is what you are going to get. So this is something called a final routing table. Okay. So if this is the final routing table, the values you are going to get. So this is the final routing table you are going to get for the particular graph. Okay. So in this table, what are you going to control? So here, if you take in this network or graph, you can take any node as their source node and you can take any node as their destination. From this routing table, you can easily find which is the shortest path. For example, if you take, you are going to reach from A to G. For example, if you take this diagram, source node is A. So source node is A. Okay. So destination node is G. So destination node is G. So in this particular graph, we are going to have a two-path layer. So this two path, which is the shortest path, is going to take. Okay. So here in this particular way, A to G, shortest path is 2, and this path will be taken. That is A to F, F to G. So this is how we are going to come to conclusion by using this final routing table, which is the shortest path of the packet to reach the destination. So this is the Bellman-Ford algorithm, right?